Okay, good afternoon, students. In the last class, I explained the test cases, then the Venn diagram and the functional testing. Now we are going to study about the structural testing. Afterwards, you are going to study the comparison between the functional testing and the structural testing. Later, you are going to study about the error and fault taxonomies. And the last topic of the chapter is levels of testing. So these things I'm going to cover in this class. So in the previous class, I already explained what is functional testing, right? Functional testing is also called as the black box testing. Here in the functional testing, each program is viewed as a function and it maps the input to the outputs. Why it is called as black box testing? Because the testing in the black box testing, the implementation details is not known to the testing persons. Only they are mapping the input to the output. That's based on that they are going to test the system. Hence it is called as the functional testing or the black box testing. And the advantages that I explained already, independent of functional testing is independent of how the software is implemented. And if the implementation changes, test cases are still useful and we can make use of the same test cases. And here in the functional testing, both the software development or the implementation phase and the test case developments will be performed in parallel so that we can minimize the time. But the disadvantages of the functional testing are redundancies may exist among the test cases and the possibilities of the gap. So these are the two major disadvantages. One is the redundancy and the possibility of the occurrence of the gap. So next we'll see this also explained, right? How we are using the Venn diagrams in case of functional testing. Next we'll move on to the structural testing. As I said, structural testing is also called as the white box testing and it is also called as the clear box testing. Understood? The structural testing is called as the white box testing and it is also called as the clear box testing, because here the structural testing is mainly concentrating on the implementation details. So whereas the functional testing, it was just stressing upon the mapping of for input to the output. But in the structural testing stress upon or it concentrates on the implementation details, and hence it is known as the clear box testing or the white box testing. So the structural testing is having the ability to see inside the block box. Inside the block box means here in the functional testing, nothing is visible in the block box, right? So nothing is visible in the black box, but the structural testing is trying to see what is there inside the black box. Okay, hence it is called as the white box testing or the clear box testing. So structural testing is stressing upon to see inside the black box and allows the tester to identify the test cases. Okay, the structural testing stress upon or concentrates on the implementation details are the inner details of the black box, and and it allows the tester to identify the test cases based upon the implementation details. Understood? So based upon the implementation details, the tester is going to define or determine the test cases. And here the structural testing is mainly using the concepts of the linear graph theory. So graph theory you are already studied, right? Those concepts, the structural testing is making use of it to perform the testing on the developed process. And here the structural testing stressing upon the theoretical basic concepts. Okay, so it is stressing upon the theoretical basic concepts and definitions and use of the test coverage metrics. Understood? structural testing is concentrating or stressing upon the theoretical basic concepts of the linear graph theory, and it is also concentrating on the definitions and use of the test coverage metrics. And we'll see here, we'll see the structural test case identification methods. So once again, like in the functional testing, we used the two methods, right? Method A and method B. Here also we are considering the same two methods, method A and method B, which are used to develop the system. And next we'll see the test cases, how the test cases are determined in case of the structural testing. So if you see the functional testing, all the test cases are defined in the specification behavior, right? So if you see this here, see here, all the test cases are defined within the specification behavior or within the specification behavior circle, right? But here in the structural testing, see here, the test cases are defined within the program behavior. Okay, see the difference in the functional testing. The test cases are defined within the specification behavior, whereas in the structural testing method, the test cases are defined within the program behavior. That is the one major difference. Okay, understood? So the first major difference is in the functional testing, it simply maps the input to the output, whereas the structural testing stresses upon the implementation details of the system. Understood? But the functional testing is mainly concentrates on mapping of input to the output, whereas the structural testing concentrates on the inner of the black box testing, that is the implementation details of the black box. Understood? That is the structural testing. And whereas in the functional testing, all the test cases are defined within the specification behavioral circle, but in the structural testing, the test cases are defined within the program behavioral circle. Understood? Clear the difference? And here in we have two methods, method A and method B, whereas method A make use of a more number of test cases, whereas method B makes use of less number of test cases. As I explained in the functional testing, that the number of test cases are not important, but how those test cases are used or executed in order to find the errors or in order to find the defects in the developed system. So that is more important. So more important in the testing process is identifying the defects or faults in the developed product. So we can use less number of test cases or more number of test cases. It doesn't matter. But what matters is the identification of the defects or faults in the developed product. So this is about the structural testing. Understood? Structural testing is also called as what? White box testing or the clear box testing. Why it is called as the clear box or the white box testing? Because the structural testing is trying to see inside the black box which is there in the function testing, right? In the function testing, the development phase or the implementation phase was just represented as the black box. Nothing is visible to the tester. Whereas in the structural testing, the structural testing is trying to see inside the black box, means it is stressing upon the implementation details, so that here we are using the test cases in the program behavioral phase rather than the specification phase. So this is about the structural testing. Any doubt in structural testing? Yes? Any doubt, Sharanya? Sharanya, any doubt?
No, ma'am.
Okay, then we'll move on to the functional testing. Also, you understood, right? Yes, functional testing and the structural testing is over. Next, we'll move on to the difference between the functional and the structural testing, or we can say the comparison between the functional and structural testing. As we know that to identify the test cases, we are using two types of testing methods, right? One is the functional testing and the other one is the structural testing. So by using these two testing methods, we are going to identify or define the test cases. Then which one is better? Whether the functional testing is better or the structural testing method is best. We'll go through the literature. So as we go through the literature, one of the person says named by Robert Poston, he writes that the structural testing tool has been wasting the testers' time since the 1970s. Please see this. So, as we go through the literature, the person called Robert Poston writes that the structural testing tool has been wasting the testers' time since the 1970s. Means, according to his opinion, he says that the structural testing tool is a time wasting tool. Means we are simply wasting the time by using the structural testing tool. But Edward Miller says that, so one more person called as Edward Miller says that branch coverage or the structural testing method is attaining a 85% of or better result when compared to the functional testing. Okay, that is the Edward Miller. He says that the structural testing method attains a 85% of the positive result or more than 85% of the result when compared to the functional testing. Understood? This is according to the literature by the Robert Poston and the Edward Miller. So here the functional testing, as we know that it uses only the specifications to identify the test cases. Which are what are these specifications? So before the designing of the uh, product starts, so first we are collecting the requirements from the users or from the customers, right? So once we collect the requirements, then we are preparing the specification document, and that is called as the specifications. Okay, and functional testing uses only those specifications to identify the test cases, whereas the structural testing uses the program's source code, or it uses the implementation details for identifying the test cases. Understood the difference? First, functional testing uses only the specifications, whereas the structural testing uses the implementation details or the program source code for identifying the test cases. Okay, then which one is best? We can't say that a single approach is best. Okay, because if we use only the functional testing, it will not solve the entire problem. Or if we use only the structural testing, it will not solve the all the problems. So if we make use of the combination of these two, so that some of the errors that are not identified through the functional testing can be solved by using the structural testing. Or if the structural testing is unable to identify some of the errors, then by using the functional testing we can identify or detect those errors or the faults. Hence we can say that any one of the approach is not sufficient for the testing. So if we use the combination of both the testing approaches, then we'll get the better results. So hence the finally debate says that a single approach is not efficient to perform the testing process, but if we use the combination of both, means if we use the combination of functional testing as well as the structural testing, then it satisfies most of the user requirements by identifying the faults or the errors. Right? Understood? So this is the debate about the functional versus structural testing techniques. See here, uh, see here, when that is the case, so the final conclusion that if we use the functional test cases along with the structural test cases, the problems which are faced in the functional testing, which are the disadvantages of functional testing? There may be a chance that redundancies may occur in different test cases and the gaps may occur in the software developed. So these are the two disadvantages, and these two disadvantages can be recognized and resolved if we use the structural testing method along with the functional testing method. Okay, so if we use the combination of both the functional testing and the structural testing, the then we can cover the metrics with the twin problems that are redundancies and gaps faced by the functional testing, and this can be easily recognized and resolved if we use the structural testing method along with the functional testing method. So this is the final conclusion when we comparing the functional testing method and the structural testing method. So both the testing methods are important and both we have to use in order to identify or determine the test cases. Okay, so because each method is having its own advantage and the disadvantage, but if we combine both, we can minimize the number of disadvantages and this leads to the better testing approach. Understood? Any doubt here? Any doubt? Okay, so here once again we are using the Venn diagram to differentiate the sources of test cases. So here once again we have the functional testing at the left side and the structural testing. As I said, functional testing is mainly deals with the specification of the system, whereas the structural testing or the white box testing is concentrates on the programming details or the implementation details of the system. So S indicates the specification behavior and P indicates the program behavior. So functional testing is concentrating on the specification behavior of the system, whereas the structural testing is concentrating on the program behavior of the system. Okay, then this intersection indicates that even though n number of specifications are defined, among them only few are implemented or few are programmed. Hence, so if it is not possible to perform the functional testing or if it is not possible to identify all the errors with the help of the functional testing, then we can use the structural testing and we can identify some of the errors or the faults that are not covered through the functional testing. Understood? So this is about the functional versus structural testing debate. Understood? Any doubt? Gaurav? Any doubt?
No, ma'am.
Okay. Next topic is so before moving on to that next topic, so here one more subsection is there, means testing as a craft. Means when actually the testing starts, once the product is developed, right? Once the product is at the final stage, then we are going to perform the testing, right? But before performing the testing, first we need to know when actually the errors or the fault occurs and at what different phases there is a possibility of the errors or the faults. So when we know what kind of error we are prone to make, so you already studied the software engineering, right? In the previous semester, have you studied the software engineering? Yes, Sharanya, Gaurav?
Yes, ma'am.
Well, you have studied the software engineering. In that, you have studied the software development life cycle, right? Yes, DLC life cycle. That you have studied waterfall model. Yes, waterfall model or the software development life cycle. So first we'll start with requirements. Collecting the requirements, then requirement specification, then designing the system, developing the system, and finally testing, and the last step is the maintenance or managing, right? So what is the first step? First step is the collection of the requirements. So once the requirements are collected, then you are preparing the specification document. Once the specification document is ready, then you are going to start the designing of the system. Once the design completes, then actual implementation starts. And here, in each phase, there is a chance that the errors may occur. So, during the collection of the requirements, or during the design phase, or during the implementation phase, there is a chance that the errors may occur or the faults may occur. So, if the errors occurs and when you are executing the system, obviously it leads to the failure of the system, right? So once the failure occurs, then what you have to do? You have to identify what types of errors are occurred, then how to debug those errors or faults. Right. So that is the first step. So first we need to know what kind of errors may occur during the different phases of the development. During the requirements phase or during the design phase or during the development phase, there is a chance of errors to occur. And if you know what kind of faults are likely to reside in the software to be tested. So if your design is the erroneous design, then obviously it leads to the faulty system, right? So if you designed the system in an erroneous manner, then it leads to the faulty system. If the system is a faulty system and when you're executing it, obviously it leads to the failure of the system. Right. So hence you need to know before testing the system, first you need to know what kind of errors may occur during the specification phase or design phase or implementation phase. And if you know what kind of faults are likely to occur due to the erroneous design or erroneous implementation, then where actually these faults reside, that if you know, then we can properly identify or define the test cases by using the different test case identification methods. So here you study two identification methods, right? Functional testing and the structural testing. So we can define the test cases by using these test case identification method, and we can employ the appropriate method, right? So that we can test the developed system. So hence this is called as the hence this is means the testing is called as a craft rather than it is just a job or the work, but the testing is called as the craft because it is a what we can say that it is a continuous process again and again. So first we'll test the system. If errors occurs, then we'll go back to the previous stage and once again we'll continue the thing, right? Suppose in the design phase if the errors occurs, and during the implementation if the errors occurs, and testing process you are identifying the errors, right? Then you will go back to the design phase and you try to debug the errors, and you will come to the implementation phase and you try to minimize the errors, and then once again testing happens. So it is a iterative process, means it is a continuous process. We'll continue the testing process until we get the required product without any errors, and hence the testing is called as a craft rather than the work or the job. Understood? So why the testing is called as a craft? Because before we start the developing or designing the product or the system, first we need to know what kind of errors may occur during the different phases of the system development. And if you know what kind of errors occurs, then if you know what kind of faults are likely to reside in the software to be tested, then we can make use of different case identification methods such as functional testing or structural testing methods, and we can employ the suitable methods and we are going to identify the errors. And this is the iterative process and it continues until we get the system with zero errors or with no faults, and hence the testing process is called as a craft rather than the job or the work. So this is about the testing as a craft. Any doubt? Okay, next we'll move on to the error and fault taxonomies. So, in the first class itself, while discussing about the basic definitions, I explained what is an error and what is a fault, right? So, we'll see the classification of error and fault here. So, the definition of error and fault is basically leads to the distinction between the process and the product. Okay, error and fault directly we are relating to the difference between the process and product. So what is a process and what is the product? What is a process? The process refers to how we do something. Okay, process means what we do, that is represented by a process, and the product is the end result of the process. Suppose if I give an example, is development of an app. Okay, so I'll ask you people to develop one app for the chatting. Chatting means exchanging the messages in terms of text, image, or the video. So that app I want. Okay, then first what you're going to do, you're collecting the requirements, then you're preparing the specification document, then you're designing, and finally you're implementing the app, right? The how we are doing that relates to the process. Then what is the product? It is nothing but the end product. What is the end product? The app that is capable of exchanging the messages, audio, or the video between the users or between the devices, and that is called as the product. Understood the difference between a process and the product? Any doubt? Suraj suraj
No, ma'am.
understood what the process is and the what the product is? Okay,
Yes.
the product means if you consider the mobile, that mobile is the end product, right? Mobile is the end product. The process is how to develop that mobile is the process. Understood? Any doubt? The difference between the process and product. Process tells how we do something or how we develop the system is called as the process, and the product is the end result of the process. And if we consider the testing and the software quality assurance SQA, we'll see this. So testing is clearly more product oriented. Means once the product is developed, then we'll perform the testing on the developed product, and we are going to identify the faults or the defects in the system, right? So we are mainly concentrating on the product which is already developed, and we are going to test that in order to identify the faults or the defects or the errors in the developed product. But the software quality assurance tries to improve the product by improving the process. Right. The process, suppose, as I said, if you are implementing the chat box so that you can exchange the message in terms of text, audio, video, or the images. Right. So that process is improved with the help of the software quality assurance. Okay. Software quality assurance tries to improve the product by improving the process, whereas the testing is clearly the product oriented, whereas the SQE is a process oriented. It is trying to improve the process so that the errors or the faults can be minimized, whereas the testing is mainly testing the product, developed product. Understood the difference between the testing and the software quality assurance? And here we are discussing about the classification of the faults or the errors. So here the faults can be classified into different categories, or the faults can be classified in several ways depending on the severity. So the faults are can be classified into mild or the moderate, annoying, disturbing, serious, very serious, extreme, intolerable, catastrophic, and infectious. So these are the 10 different types of classification of faults based on the severity. Here no explanation, just here you have to specify the classification of the faults. Right, mild means it is misspelled word or the severity is very less. Moderate, it is a misleading or redundant information. Annoying, truncated names. So for example, if you're giving the bill for the 0 rupees, no meaning for that, right? It's that fault is called as the annoying fault. And next one is disturbing. Some transactions are not processed. The best example for this is when you are performing the money transfer using banks, then some in some cases the amount is not transferred from your account to some other account. Means it is that fault is called as the disturbing fault, because the transactions or the operations are not processed and not completed. Such type of faults are said to be disturbing. And second, the fifth one is the serious transaction, lose a transaction. In some cases, abrupt stop occurs or the abrupt execution occurs. Then, in such cases, the effect is serious, and that fault is called as the serious fault. Next one is very serious. Incorrect transaction execution means the operation is performed, but it is in a incorrect manner. Next one is extreme. Frequent very serious errors means very serious faults occurs again and again, and that fault is called as extreme fault. Intolerable. Intolerable means database corruption. So normally we know that during the in the banking transaction they make use of the databases. If the databases themselves are corrupted or modified, or some data is deleted, then that type of error or the fault is intolerable fault. Next one is the catastrophic system shutdown. So if something happens, nothing can be done, and it leads to the shutdowning of the system, and that type of fault is called as the catastrophic fault. Next one is infectious shutdown that spreads to other. Means if one system is shut down, then it causes other systems to shut down, and that is called as infectious. So these are the different types of faults classified based on the severity. Like that, we have other types of faults such as the input output faults. Here, the fault occurs in case of the inputs and outputs. So, the example for input fault is correct input not accepted, but incorrect input is accepted. Then description is wrong or missing. Then parameters are wrong or missing. Next one is the output wrong format or the wrong result, correct result at the wrong time, incomplete result or the missing result, spurious results, spelling or the grammar mistake, and the cosmetic results. So these are the examples for the input output faults. Similarly, we have the logic faults, missing cases or the duplicate cases. Missing cases, some cases are not written, or the some cases are duplicated, means written again and again, or the extreme condition neglected. Misinterpretation. We have defined something, but that is understood in a different manner, that is called as the misinterpretation. Next one is the missing condition, extraneous conditions, then test of the wrong variable, incorrect loop iterations, and wrong operators. So instead of less than, if we write it as less than or equal to, or instead of less than or equal to, if we write less than. So such type of faults are said to be logic faults. Next, we have the computation faults and interface faults. Computation faults, if you use the incorrect algorithm or the missing computation, incorrect operand or the operation, parenthesis error. So this type of errors you already experienced, right? So for example, parenthesis error. So instead of round parenthesis, if you use the square brackets or the flower brackets, then also error occurs. Or if you use the incorrect operand or the operation, these things you're already familiar, and you're experienced when you're doing the programs, right? And next one is the wrong built-in function. So if you use the built-in functions, so the best example is when during the beginning, when you're writing the C programming codes, there you are familiar with the errors, right? In the wrong built-in function means instead of printf, if you use just print, then the error occurs. Or instead of scanf, if you just use a scan, then also error occurs. So because you're representing the built-in function in a wrong way, then the error occurs, right? These errors you already familiar, right? Next one is the interface faults. These errors you come across when you're doing the what microprocessor laboratory, when you're using the hardware devices to connect, and there you're using the interrupts, then such this type of faults will occur. First one is the incorrect interrupt handling, IO timing, call to wrong procedure, call to non-existent procedure, parameter mismatch or incompatible types, superflows inclusion, etc. These are the different interface faults. Next, we have the data faults, incorrect initialization. So the best example is when you're using the integer operation, sorry, int a comma b comma c, and while performing the operation, if you use the floating point, then obviously the error occurs. So because there is a mismatch in integer and the floating point, right? Then that is the example for incorrect initialization. Next, we have the incorrect storage or the access. So when you're doing the program and you're trying to access the memory, and if you're doing it in a wrong way, then it leads to the incorrect storage or the access. Next one is the wrong flag or index value. So that you experience while doing the microprocessor programs, right? Next one is incorrect packing or unpacking, wrong variable used, wrong data reference, or scaling or units error, incorrect data dimension, incorrect subscription, etc. These are the different types of data faults. Understood? So, error or fault taxonomies. So, here the errors or faults are classified based on the severity. How many are classified? 10 faults are there based on the severity. Next, we have the input output faults, logic faults, computation faults, interface faults, and the data faults. So, this is about uh, uh, the error and the fault taxonomies. The last topic of the chapter is levels of testing. So far, so many times I said that we are using the testing process. We are going to test the developed system by using the functional testing, structural testing, etc., etc. But here we have not specified the levels of testing, right? So hence the last topic is the levels of testing. Once again, here we are considering the waterfall model of the software development life cycle. So levels of testing echoes the levels of abstraction. Okay, levels of testing echoes the levels of abstraction, and this is found in the waterfall model of the software development life cycle. And here at each level, see here we have the requirement specification, design, preliminary design, and the detailed design. And after that, once the design is completed, we are implementing the system. And after that, we are performing the unit testing, integration testing, and the system testing. Then how they are related. So here we are considering in case of the functional testing. Here we have three levels of definitions. One is the requirement specification, next one is the preliminary design, and the detailed design. And these three definitions are corresponding directly to three levels of testing: system testing, unit test, integration testing, and unit testing. See here, first we have the requirement specification, next is preliminary design, and the detailed design. And after designing the coding, or once the design completes, we'll move on to the coding phase, right? So here, when we compare with the designing by using the functional testing, as I said, the functional testing is directly concentrating on the specifications of the system rather than the implementation details, right? So requirement specification is corresponds to the system design, system testing. Preliminary design is corresponds to integration testing, and detailed design is corresponds to unit testing. So here we have three levels of testing for each one. So once the design is completed, we are performing the unit testing and the integration testing. And once the system is developed, we are performing the system testing for the given requirements. So when we are performing the system design, system testing, we are mainly concentrating on whether the system is working according to the requirements specified during the requirement specification space, right? So here we are just comparing the requirement specification along with the obtained output, whether the obtained output is satisfying the requirements of the user or the customer. So that we are doing in the system testing. We are just comparing, or we are just relating the obtained output with the requirements, whether the obtained output is satisfying the user requirements or customer requirements or not, that we are concentrating. So hence we are performing the three levels of testing: system testing, integration testing, and the unit testing. So system testing is performed for the requirement specification, whereas the integration testing is performed with the preliminary design, and the unit testing is performed with the detailed design. Okay. Next is so here we say that the integration testing and the unit testing we are performing with the detailed design, right? So when if you compare with the functional testing and the structural testing, the functional testing is more appropriate at the system level. Understood? Functional testing is more appropriate at the system level, whereas the structural testing is most suitable at the unit level. Okay, the the structural testing is most appropriate at the unit level, whereas the system testing is more appropriate at the system level. Understood? Functional testing and the structural testing. Functional testing, when we are performing, or at what level we are performing, we are performing the functional testing at the system level. Means we are mainly concentrating on whether the developed product is giving the output according to the user requirements or not, that we are testing at, by using the functional testing, whereas the implementation details are tested by using the structural testing. Okay, structural testing is suitable at the unit level, whereas the functional testing is suitable at the system level. So here we are performing three levels of testing: one at the system level and two at the unit level. One is called as the integration testing and the other one is called as the unit testing. So this is about the levels of testing. Okay, so this is about the levels of testing. We have three levels of testing: system testing, integration testing, and unit testing. And if you compare with the functional and structural testing, functional testing is suitable at the system level, whereas the structural testing is suitable at the unit level. Means if you want to test the system, once the design is completed, we are using the structural testing strategy rather than the functional testing. But once the whole system is completed, we are using the functional testing method to test the developed product. Okay, so this is about the levels of abstraction and levels of testing. So levels of testing is directly leads to the levels of abstraction found in the waterfall model of the software development life cycle. Because here we have the three types of definitions, right? Specifications, preliminary designs, and the detailed design. And we have three levels of testing: system testing, integration testing, and unit testing. Whereas the system testing is relate to the requirements and specification, whereas the integration and unit testings are related to the preliminary and detailed designing phases. Okay, this is about the levels of abstraction, and this completes the first chapter of first textbook. And the remaining topics are covered from the other textbook called as the software testing by Aditya P. Mathur. So two chapters are included for module 1. One chapter is from the craftsman approach, that is the first textbook 1, and the remaining topics are covered from the other textbook, that is textbook 3. Okay, that is software testing by Aditya P. Mathur. So the first chapter of first textbook I completed. So tomorrow I will start the remaining topics from the third chapter. Okay, any doubt here? Understood all of you? Any doubt? You can give the attendance. Any doubt? Sharanya, Suraj, Gaurav. Any doubt?
No, ma'am.
Oh, so first chapter is completed. I will give the notes on this chapter. I will send it afterwards. So once I'll complete the entire module, first module, afterwards I'm giving the notes for the first module topics. Is it okay? Okay. Any doubt?
Yes, ma'am.
Any doubt here? If no doubt, I'll stop here. Shall I engage the class tomorrow also at 1 p.m.? Because Friday and Saturday holiday, I will not get the class. So ನಿಮಗೆ ಕ್ಲಾಸಸ್ಸು ಬೇಗ ಮುಗಿಸ್ಬೇಕಾ? You have to complete the syllabus, right?
ಮ್ಯಾಮ್ ಅದು ಆಗಿದ ತಕ್ಷಣನೇ ಮತ್ತೆ ಲ್ಯಾಬ್ ಇದೆ ಮ್ಯಾಮ್.
ಎಷ್ಟೊತ್ತಿಗಿದೆ? ನಾಳೆ 2:30 ಲ್ಯಾಬ್ ಇರೋದು.
12:45 ತನಕ ಕ್ಲಾಸ್ ಇದೆ, ಮತ್ತೆ 2:30 ಲ್ಯಾಬ್ ಇದೆ.
ನಾನು ಜಾಸ್ತಿ ಹೊತ್ತು ತಗೊಳ್ಳಲ್ಲ, ಒಂದು ಅರ್ಧ ಗಂಟೆ ಕ್ಲಾಸ್ ತಗೊಂಡ್ಬಿಡ್ತೀನಿ ನಾಳೆ ಮತ್ತೆ ನಾಡಿದ್ದು. ಸೊ ದಟ್ ಫ್ರೈಡೆ ಸಾಟರ್ಡೆ ಕ್ಲಾಸ್ ಇಲ್ಲಿ ನಿಮಗೆ ಮೇಕಪ್ ಆಗತ್ತೆ ಅಂತ.
ಎಸ್ ಮ್ಯಾಮ್.
ಓಕೆನಾ ಶರಣ್ಯ, ಸಚಿನ್?
ಓಕೆ ಮ್ಯಾಮ್.
ನಾಳೆ 1 o'clock ಇವತ್ತು ತಗೊಂಡಲ್ಲ, ಅದೇ ತರ ನಾಳೆ 1 o'clock ತಗೋತೀನಿ, ನಾಡಿದ್ದು ತಗೊಂತೀನಿ. ಹಾಫ್ ಆನ್ ಅವರ್ ಕ್ಲಾಸ್. ಓಕೆ ಅಲ್ಲ? ಸೊ ದಟ್ ಐ ಕ್ಯಾನ್ ಕಂಪ್ಲೀಟ್ ದ ಸಿಲೆಬಸ್. ಬಿಕಾಸ್ ಬೇರೆ ನೀವು ಸಬ್ಜೆಕ್ಟ್ಸ್ ಎಲ್ಲ ತುಂಬಾ ಕವರ್ ಆಗಿದೆ ಅಲ್ವಾ, ಅದಕ್ಕೋಸ್ಕರ ನಿಮ್ ಸಿಲೆಬಸ್ ಕಂಪ್ಲೀಟ್ ಆಗ್ಬೇಕಲ್ಲ ಇನ್ನು 2 ತಿಂಗಳೊಳಗೆ. ಡಿಸೆಂಬರ್ 17th ಇಸ್ ದ ಲಾಸ್ಟ್ ವರ್ಕಿಂಗ್ ಡೇ. ಅಷ್ಟರೊಳಗೆ ನಾನು ಸಿಲೆಬಸ್ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ಬೇಕು, ಅದಕ್ಕೋಸ್ಕರ. ನಾಳೆ ನಾಡಿದ್ದು ಕ್ಲಾಸ್ ತಗೊಂತೀನಿ, ಒಂದ್ ಅರ್ಧ ಗಂಟೆ. ಓಕೆನಾ?
ಎಸ್ ಮ್ಯಾಮ್. ಎಸ್ ಮ್ಯಾಮ್.
Okay. We'll meet you tomorrow. Okay.